Discovering everything there is to know about the red planet has kept Elon Musk and NASA busy. NASA has long been interested in Mars and has sent out numerous drones to study the planet. NASA also wants humans to settle on Mars. After closely observing NASA's work on the planet for a couple of years, Musk has disclosed NASA's most alarming discovery yet. But what did they discover, and how did it work? Join us as we examine the revolutionary discoveries NASA is making on Mars and their implications for Elon Musk's Mars colonization scheme. Water on Mars that supports life is salty. The Mars of today and the Mars that predated it by almost 3 billion years are two distinct planets. The red planet is now a dry, icy place that may be devoid of all life, and there is little evidence that humans can establish a self-sustaining colony there. But in the past, it was only sometimes the case. Mars lost its magnetic field to shield itself from the solar wind, which mostly stripped the planet's atmosphere away. According to recent studies and data, it was once a planet with flowing water. Another possibility is that the Earth is not as lifeless and arid as we believe. In several sites where unexplained streaks were observed, researchers found evidence of hydrated minerals using an imaging spectrometer on NASA's Mars Reconnaissance spacecraft. When it was warmer than 10 Fahrenheit, or minus 23 degrees Celsius, they would appear, and when it was colder, they would disappear. This shows that water, however salty, still flows beneath the surface. As a result, the dark, winding L is known as the recurrent slope lineate may keep liquid at even lower temperatures. When it found the surface of an ice sheet surrounding the south pole of Mars, the European Mars Express orbiter furthered our understanding of the possibility of water on Mars. Dips and rises imply that there may be liquid water below. It has long been known that the red planet, like Earth, has stagnant water and ice caps at the south and north poles, but due to the cold environment, it was widely assumed that they were frozen down to their beds. The team discovered a 6.2 to 9.3 mile long surface ion mimicking the historical relations in ice sheets above subglacier lakes after analyzing the area's surface topography as supplied by Mars Express. Where there is water, there is some chance of life with enough dissolved oxygen to support microorganisms and even primitive animal life like a sponge. Mars must still be geothermally alive, with geothermal heat from magnetic activity to keep the water flowing. However, due to the varying temperatures and weather on Mars caused by the tilt of its axis of rotation, the amount of dissolved oxygen varies from location to location. Cold temperatures allow more oxygen to enter the brine, and the icy pockets near the Martian poles can have enough oxygen to support complex multicellular organisms. The Curiosity Mars rover discovered manganese oxide while exploring the 96-mile broad Gale crater on Mars. A large amount of dissolved oxygen must be present for minerals like these to form. Only after oxygen started to persist in the atmosphere about 2.5 billion years ago did magnesium oxides begin to form on Earth. However, oxygen is not always required for life, as we already know from the anaerobic species on Earth. However, its presence on Mars opens up various intriguing evolutionary possibilities, including inquiries into the possibility of human survival on the planet. To that end, NASA, the European Space Agency, and Russia just launched 2 new rovers to look for evidence of prehistoric life on Mars. Also, with the tenacity to learn more about any existing or extant life on the planet, the rover is now investigating the geologically rich G crater. A delta created 3.5 billion years ago at the confluence of a lake and Martian river may be found inside the G crater, which is 28 miles across. Perseverance will be looking into and gathering samples of sedimentary rock made up of different sized particles. Different climates on Mars have been settled in what was once an aquatic environment. The main components of Mars' atmosphere, which give it its current rusty tan hue, are carbon dioxide, argon gases, nitrogen, and oxidized dust particles that are kicked up from the planet's surface. Mars experiences meteorological conditions and temperature fluctuations similar to Earth, despite having a thin atmosphere. On the other hand, Mars encounters planet-engulfing dust storms that can linger for days, which makes it challenging for Mars exploration missions. NASA's inventiveness. Due to the dust storm around Jeremy, the Mars helicopter's 19th trip, which was scheduled for January 29th, was postponed. The Mars Opportunity rover was destroyed by a powerful dust storm that swept across the red planet, rendering it completely inoperable and its solar panels useless for days. Massive dust storms are caused when airborne dust particles absorb sunlight, warming the atmosphere, which causes warm pockets of air to flow to colder regions, creating strong winds that lift more dust off the ground. As a result, the atmosphere becomes even hotter and produces more wind and dust, which spreads across a wide area. Mars is the only planet known to exhibit this type of weather phenomenon, according to the Mars Reconnaissance orbiter's detection of carbon dioxide and snow clouds that were dropping to the surface. As the fourth planet, its daily temperatures range from minus 195 degrees Fahrenheit at the north and south poles to 70 degrees Fahrenheit at noon. Mars has a longer year Earth because Mars is farther from the Sun. Like the Earth, Mars has an inclination that causes some areas of the planet to receive direct sunlight. Its orbit, which is more elongated overall than any of the other main planets, gives Mars its harsh seasons. The northern hemisphere has a brief, bitter winter, while the southern hemisphere has a brief, hot summer when Mars is closest to the Sun. But because it is angled toward the Sun in the southern hemisphere during Mars' closest approach to the Sun, the northern hemisphere has a long, pleasant summer, has a long, chilly winter. The atmosphere and weather on Mars today are primarily a result of the loss of its magnetic field. Although little is known about the interior makeup of Mars's core, readings from meteorites and seismic data from NASA's InSight mission show that it is composed of molten iron enriched with sulfur. These currents are what power Earth's magnetic field. The planet's composition has helped NASA scientists better grasp what transpired to deprive Mars of its magnetic field. Convective currents were created by the iron-sulfur-hydrogen composition that was powerful enough to produce a protective magnetic field around the planet. Still, it was only temporary until the currents lost their ability to do so. The solar wind might have gradually stripped Mars' atmosphere away without a shielding magnetosphere, till the surface of the red planet was entirely eroded. Water and other elements were allowed to go. Due to two significant meteorite impacts on Christmas Eve last year, Mars suffered near-surface seismic waves. Such seismic waves had never before been observed on a planet besides Earth. The collision of the boulder, which had a diameter of between 15 and 40 feet, unleashed energy that ranged between 2.5 and 10 kilotons, or roughly the same as an atomic bomb, and the phenomena were captured by the NASA InSight lander and beamed back to Earth, and left a crater more than a football field in size. The meteorites created the biggest fresh craters yet observed in our solar system, according to Dr. Benjamin Fernando of Oxford University, and the force of the impact propagated through the crust to the main crater rather than through the planet's deeper mantle and core. Even though the event was unexpected, it gave us a ton of information that we could utilize to figure out the structure and makeup of the crust. It has mostly remained undiscovered. The stark division between Mars' northern and southern hemispheres is a distinguishing feature. Most of the craters are located in the southern hemisphere, which is primarily hilly. The greatest volcano in our solar system, Olympus Mons, which can completely engulf New Mexico, is located there. On the other hand, the northern hemisphere is mainly flat and smooth. Numerous ideas have been developed in response to the differences in the crust, which contend that the two hemispheres have different compositions and evolutionary histories. However, Impact's fresh evidence disproves these beliefs. It demonstrates that the crust might share a similar structure and composition. After the data has been thoroughly analyzed, it can offer priceless insight into how Mars was created and developed. Additionally, it can provide precise information about the environment on the red planet billions of years ago and whether or not there was actual life there. Thanks for watching the video.